you go from there.
Thanks, and I'm happy to be here. As Jun mentioned, I have the best job in the world for me because I get to look at satellite imagery all the time. I look at it from a bunch of different places. I create imagery using a bunch of different software. So that's what I'm going to talk about. But I don't know a whole lot of things. I don't know everything. I've been told that. And so I'm not telling you where everything is. I don't know where everything is. Actually, if you have a great source of data that you know of or imagery, feel free to put that in the Q&A in the Sli.do. Say, you know, I really love this particular site because it gives me excellent imagery. So that's just a little caveat. Let's see if I can, come on. There we go. So again, we've done the Sli.do.com, put questions in there, and this is recorded. But we're going to start right away. I'm going to hand it back to Bill. So go to the Sli.do that's open in a different tab on your computer. And we're going to go through the first 3 poll questions at Sli.do, just so we know, just so I kind of know what's up. So I'm looking at the Sli.do now, and it's just asking. I sent out 2 homeworks that I was hoping people might do beforehand, just to familiarize themselves with different data structures. And I think one was on Panoply, which is a way to look at netcdf files. So I'm looking at that. Did you do the assigned homeworks? So I'm kind of curious. This is the first time we've done this kind of thing. And I'm kind of curious to know how, if we tell students to do things at the beginning, how many of them actually do that? Because I have no idea. And there's no way for us to track that either. So I see, I also like Sli.do in this case. It actually tells you how many people have done it, but I like to look at the numbers and try to figure out how many people have responded just by the changes in percentages. A little number geeky of me, but that's just how I work.
Right now we have 45 people on, or 45 entities on. Of course, some of those are the instructors. So anyway.
So I'm happy to see go to the next question. I'm happy to see that most people did that. So that makes me feel good. So I didn't know if people would be doing these homeworks. This is more of a, you know, what do you need out of this short course? Because I'm doing this short course. I love talking about data. I love talking about where I get data, how to create imagery, how to download imagery. But I'm just not sure if people are here to say, oh, I know about this link, or I know how to use, you know, SatPy to make imagery. I just don't know exactly where I'm going. So a little word cloud action here would be helpful. But while you're doing that, I'm going to go to my next slide and just talk about me. So there's my picture. I took it today because you can see I'm wearing the same shirt that's on the picture. So I am from Pennsylvania. As Jun said, I went to Penn State. I actually grew up in State College. So if anyone is here from Penn State, if you're in State College now, you want to go by my childhood house, it's on Ellen Avenue. So I have my special thrill here is I really find it interesting when you have extreme weather or something that's just unusual. I remember a streak of days back in 1985 when we had the same high temperature for 4 days. It was 81 for a high temperature for 4 days, which just doesn't happen very often. I thought that was kind of cool. My special skill is I remember just about any song or lyric that I've ever heard. And my special ill is that as a result, I always have a song playing in my head. So at the moment, the song that's kind of on repeat in my mind right now is from 1977, from Flash in the Pan, Hey St. Peter. So you can look that up a little bit later. You can dance to it. It's got a beat, as they used to say. So my special thrills, skills, ills, and drills. My special drill is I can usually write a blog post. Some blog posts really write themselves. I can do one in about 15 minutes if it's a really interesting image. So I do make training for the Weather Service. I write blog posts. There are 2 links there if you want to look at them. I write software for Meteosat X, and I put this headshot in here because the one I gave to the AMS, I really don't like, but it was the only one I had at the time that I could find. So that's what I look like today. I'm getting new glasses next week, so that's going to be obsolete pretty soon. Why don't we go to the next poll question, Bill? And I'm kind of wondering, how do you use satellite imagery? Is it just because it's awesome to look at? That's my opinion. Or do you use it? Are you using it in research? Has your major professor told you, I want you to look at this type of satellite imagery to figure out how we can detect smoke at night, which I would like someone to be able to do because that's an actual operational need in the Weather Service. Smoke detection during the day is fairly easy. You can use true color imagery. Smoke detection at night is much, much more challenging because a lot of smoke, as you might learn at the next one, is transparent to infrared transparent to infrared radiation, which is what's mostly there at night, unless you have day-night band images. So we're going to start with polar orbiters. My assumption is that you all know the difference between a geostationary and a polar orbiter. So a polar orbiter, as the name says, is a sun synchronous. It's in a sun synchronous orbit, meaning it's passing over the equator at the same time every day, same local time every day. And I'm going to mostly focus on SUMI NPP and VIIRS, which data from SUMI NPP and NOAA 20, which is to say VIIRS. So the senior moment on visible infrared imaging. No. I'll have to look up. Someone type the acronym for VIIRS into the chat box for everybody. I'm blanking on it right now. The V and the I are visible in infrared. Okay, anyway, on the chart here are the 22 channels on VIIRS. So one of my questions is, do you know this by heart? I know them for GOES. I know the channels by heart for GOES-R, for GOES 16 and 17, for ABI, for AMI, but I do not know it for VIIRS. So we have the moderate resolution bands on top, then there's the day-night band, then the 5 very high resolution imager resolution bands, which I do know by heart. So that's what we're going to start with. Where can you find imagery for these kind of satellite images? And here we have just a list of them that I know of. And again, I don't know where everything is, but there are places out there we can find really nice imagery from VIIRS. And I actually made all of those purple boxes clickable, but I found out in a different telecon earlier this week that when I click on them, it opens up, Microsoft Edge, and that disables my microphone. So I'm not going to be clicking on them, but if you download this, if you get this PowerPoint, which I believe is going to be made available to you, you can click on them and it'll open up a web browser with these particular websites in them. So I'm just going to go through what you can do at all of these different websites, what kind of data you can find. So most of this is, you would be just looking at imagery. Some of them have a nice archive, so you can go backward in time to find a lot of imagery. Some of them, like the FTP servers at the direct broadcast sites, they have both a combination of imagery and they might also have HDF files and NetCDF files that you would then use a software package of your choice to look at to transform those files into some kind of usable image or usable data. So I got to move something. It's in the way. I can't see what I'm talking about. JSTAR Mapper, I guess that's where I started. So the JSTAR Mapper includes imagery from 4 satellites. They're all polar orbiters. And I would say it's a useful site to me because I like to look sometimes at GCOM WT. So GCOM W2 is a polar orbiter that's controlled by JAXA, which is the Japanese equivalent of NASA. So it's a Japanese satellite. and it has some really interesting fields, as we'll see. So like I say, some of the fields in this website are hard to find elsewhere, or hard for me to find elsewhere because I just don't know where. I just haven't found them yet. And I have to find things a couple of times before it cements in my mind, oh, this is where I can find that data. Or that I remember, oh yeah, I've got to bookmark this so I can find it. So on the slide right now, you see the JSTAR mapper, the JSTAR mapping of, got to put on my glasses now to see my screen. So we're looking at SUMI NPP M-band fire radiative power. That's shown over, I believe that's one of the fires burning on Monday in East Central Arizona. I didn't look to see what the name of that particular fire is. So one of the interesting things you can see there. So explore the JSTAR mapper and you'll see a whole lot of interesting polar orbiting.
Scott, I believe you lost your audio. Nope. No, still can't hear you.
Okay.
I think we can hear you now.
You can hear me?
Yes,
Yes.
you're back.
Okay, I don't know what's going on. Just a little Zoom ghoul there entered my computer, I guess. Okay, we're looking at GCOM information. So this is something on the JSTAR mapper. You can look at GCOM data, and it has. Here are the products you can find from both GCOM or Sentinel. I like this information because if you look at a satellite image, say something from GOES 16, the visible and the infrared in there tell you interesting things. But a lot of the interesting information from satellite is coming from the products. And the products give you a better feel for maybe something that you can't quite see in the satellite image. And that's especially true for Sentinel's TROPOMI products. So this is can't remember what TROPOMI means either, but it's an imager, tropospheric ozone mapping imager. That would be my guess. That's looking at different chemical species in the atmosphere. And I have a picture of that too. And also one of the non-product layers that's really important on the JSTAR mapper, I don't think I've seen this anywhere else, is that you can see granules. So the information from SUMI NPP and from NOAA 20 comes in discrete packages called granules. And each one is only, it's like 15 seconds, it's 8 seconds across, and they're about 4. So it's maybe, it's less than a minute of data or a minute and a half of data as it's moving north and south, and it tells you exactly where those granules are. And it's very helpful if you're downloading data because you can just really focus on a specific region that you want. You don't have to get a whole lot of data because when you're getting VIIRS or CRIS data from NOAA 20, getting just one granule is so much easier because it reduces the data volume. So here we have TROPOMI carbon monoxide, which I thought was kind of interesting. We have this interesting distribution of carbon monoxide, and you can look at that and you could ask your professor or your students, why do you think there's an increase in carbon monoxide over equatorial Africa, or why do you have one over coastal China? You know, the coastal China one, I think I can answer pretty easily. I'm not quite so certain about why there'd be one over equatorial Africa. So these TROPOMI images are really interesting for helping you understand what's going on in the atmosphere, because you might not be able to see this in a visible image or in an infrared. And so here we have aerosol index from TROPOMI. It's a great capture of a SAL event going on, coming off the coast of Africa, going into the Atlantic Ocean. This is a couple of days ago. It's progressed. It's a little bit farther out into the central Atlantic. So that's kind of important if you're monitoring tropical cyclogenesis. And then we have this feature over the western US that I circled in red. Could be dust, could be smoke. You just have to look a little bit more in depth to find it there. That's kind of a quick view of JSTAR. Again, I think I use it most frequently to look at the location of the granules for both NOAA 20 and for VIIRS, because it helps you really zero in on exactly what time you want to download the data from. If you're downloading data to display it from class, and we can talk about class later. VIIRS today VIIRS today does only a few things. It's looking at SUMI, NPP, and VIIRS data, both true and false color. It's a source for the day-night band. You can toggle things off and you can step forward and backward in time. I like that it has a link to the moon phase. So if you're looking at day-night band imagery, you need to know about the moon phase. And it also has a link to MODIS today, which has been around for 20 years almost. Of course, Terra and Aqua have been up there forever. Terra launched in 1999 and its MODIS is still operating. So MODIS today still has some imagery, but as I've heard people say, MODIS was your grandfather's satellite and VIIRS is today. So you can use this website to click on a sector. So there's just one image there, but it's actually broken up into sectors. And if you click on a sector, you'll see something like this, and then you can zoom in to 2,000 meter, 1,000 meter, or highest resolution, which is actually 250 meters, which is actually higher resolution than VIIRS offers. It matches MODIS's highest resolution. And of course, there's a reason that, well, I'll only say that VIIRS offers less resolution than MODIS at its highest resolution, but MODIS resolution degrades faster as you go away from nadir. So it's kind of a wash. But just some beautiful imagery. I like seeing how the green changes over the course of the year, for example. RealEarth is out there. RealEarth is what I call an aggregator. So it gathers imagery from many places and puts them in a common environment. So if you go to the website that's on there, and somehow it didn't link, it didn't become clickable. You see all the products that are available in RealEarth. There are over 500 of them. Alternately, you can just enter RealEarth, and there's a search bar there. You can enter something like CMORPH, which is a precipitation product, a precipitation total product. And you can look, and there are all those preset, all those different functions in there, the different labels. So I thought I'd actually show this live, just for a bit. So let me just do a new share. Tabs. So here we have RealEarth, and I mentioned CMORPH. So to look at that, I just type in CMORPH into the search box. So if you want a product, you just type it in there and it comes up with these different things. Let's just look at 7-day accumulation. We drag it over onto the map and we see here in Wisconsin, it's been dry for 7 days. And yes, that is true. We are in a big drought. If you go to the drought monitor page, you'll see that we're in extreme drought. So you can zoom in and out. Zoom, look somewhere. Beautiful picture of the ITCZ, for example. Have there been floods in places? Most of the looks like it's been a lot. Okay, well, so that's the 7-day accumulation ending last night from CMORPH. And then you can just click on it and it vanishes. The nice thing about RealEarth is it does have some of the products level from GOES. In particular, the derived motion winds. If I want winds, this might take a while to load. Sometimes it does. So it's going out to the server, getting the low-level winds, and it's going to display them at some point in time, I hope. The peril of a live demo. How long should I wait until I give out? Oh, there they are. Showing you the low-level winds from GOES 16 and GOES 17. And it can be difficult to find these derived products from these derived products. So just something you can use. So let's do what I was doing before. I'm getting better at changing the sharing on this. I'm kind of happy about it. Okay. NASA Worldview is out there. This has been around for a long time. And this is something you can also, if you look down at the bottom, you can change that day to a year and you can really scroll backward pretty far in time. It's showing you all sorts of products, so you can add layers. So the default on this one is it just shows you a beautiful true color image from VIIRS. I think this is from SUMI NPP. It says over here, so corrected reflectance, or as I call it, CREFL. And that's from NOAA. That's from SUMI NPP. You can do it from NOAA 20 as well. But it just shows lovely imagery. You know, you catch a little sun glint every now and then. But the Earth is a beautiful place, and sometimes I just load this up and spend maybe a minute or two looking at it because it's just so awesome to look at. But if you click on Add Layers, then this comes up, and it also has a search capability where you just enter what you're looking for. So, you know, I'm going to enter ozone here, or I could enter day-night band because this is one of the places you can look at the day-night band. That's the special instrument on both NOAA 20 and SUMI NPP. The Chinese are going to be flying one in a couple of years as well, which gives you visible imagery at night. So again, if you're tracking smoke, for example, visible imagery at night is very handy for that. And it's also nice to see, you know, you can use it to track, for example, power outages after a hurricane. You can use it at nighttime to center a hurricane more appropriately if it's in a high shear environment. Lots of uses for the day-night band. So I just note here, oops, I did scroll all the way back to 2008. So I changed the year and just scrolled back. So it's a nice way to do that. So here I've gone in there and I started typing ozone. It's one of those kind of progressive reveal search tools. So if you type in ozone, you have all these different products that are available from ozone, so you can find it fairly quickly. CIRA Slider is available as well. So if you go to the CIRA Slider, you can change the satellite from its default, which is GOES 16, to JPSS, the Joint Polar Satellite. What's that second S mean? We'll just call it JPSS system, Joint Polar Satellite System. And you can see things either from the Northern Hemisphere view or the Southern Hemisphere. So it's aggregating all the different polar passes over the poles And of course, there are a lot of them because of the orbital geometry of polar orbiters. And there are lots of different things you can look at. These are the different channels. So it shows, you can see all the M bands. So if you want to see the difference between the deep blue and the blue band, there should be a slight difference related to scattering between those two. You can look at those, and there are a lot of products you can look at that have been derived as well. So lots of RGBs, the dust RGB, the fire temperature RGB. So, you know, VIIRS has very high resolution, and you can zoom in pretty nicely on this. So if you're looking at something over the poles and you want to look at an RGB and you want very fine resolution that you're not going to get from a polar orbit, from a geostationary satellite, because you're so far away from the subsatellite point when you're at the poles, you want to use polar orbiters. Oops, direct broadcast sites are available too. So I've listed the ones I know about. Only the one at Madison, which is not FTP anymore, it's an HTTPS, so it works with all your web browsers. It contains a lot of imagery, so we could look at the imagery from the polar orbiters today, or you can look at the actual data. And the data that you get, so it's being processed with the Community Satellite Processing Package, or CSPP. It's meant to look just like class data. So you can get it a little faster than you can from NOAA class. And then what's happened is it's fed into polar, it's fed into polar to grid, which is a Python-based, it's a Python-based software package. There are a lot of descriptive blog posts on that at the link at the bottom. So you can use the data that comes from the direct broadcast site and polar to grid to grab the data and grab polar to grid and create imagery fairly quickly. Then you can get it from class. And then there are also some images here from both Alaska Fairbanks, Miami, and Hawaii. These just show images. You know, but if there's a tropical cyclone near Florida or in the Caribbean, it's pretty nice to look at Hawaii's direct broadcast site because they'll be looking at it also. Okay, we just want to jump back to my Fire and just show you. Here we have the FTP site here, and you'll notice we have different. So I don't know if you can see this. This is the website that I showed in the PowerPoint. But if I click on J01, JPSS1, which is for NOAA 20, then you see these various files for both either VIIRS or for the CRIS FSR. So or we can look at ATMS data. So there are all these different products that are available. For example, if we go to CRIS FSR, we have different timestamps. You know, I'll just click one, and if we click on an environmental data record, we see all the NuCAPS fields. So you can use, for example, SharpHigh with these NuCAPS fields to create profiles. Or you can, if you don't want to do that, you can, let's see, go back up. We look at VIIRS, and we use, you know, we have ours there. We have Oxbow SSTs. So NetCDF files, so you can create imagery from the NetCDF files, or the HDF5 files are in there as well. Or you can just look at some imagery. So if we scroll down, we have, for example, I don't know what this is going to look like, but here's the day-night band imagery from June 9th at 10:52 UTC. So there's no map on there, but I hope you can see the West Coast of the US in the image. Let's go back here. Okay, let's go back to Sli.do now. And some more questions. First, I'm going to look in the Q&A and see if there are any questions that have been asked. Okay, so someone has, yes, I'll be talking about the CIRA slider when I talk more about geostationary satellites. But that is one very popular way of looking at the atmosphere. Let's see what we are in the polls. So Bill, are we going beyond how do you use satellite imagery in your everyday life work? Okay, I'm not seeing anything from Sli.do, so I'm just going to go back and start talking about geostationary satellite. But again, go to Sli.do and ask questions. And I'm going to thank you for saying tropospheric monitoring instrument is what TROPOMI means. So Sarah relayed that to me, and the carbon monoxide over Africa was biomass burning, which surprised me because I didn't realize it was dry enough there to be burning right now in that part of Africa, but maybe it is. So as I'm talking, I also see that the Sli.do has changed. So I'm going to keep talking and just keep answer the Sli.do questions as well, you know, multitask. And Bill, if you can just advance it every now and then to a new topic. And this will give me better information about who I'm talking to. So I found this slide I thought was kind of interesting to show where are the geostationary satellites. So there are lots of them clustered in Europe and Asia. And then we have the two US ones. These are in orbit on top and they're planned on the bottom. So we're going to talk about some of these, and some of them I'm not going to be, some of them the imagery is very hard to find. So it's very hard to find imagery online from the Russian satellite, similarly for the Indian satellite. But you can find FY imagery, GK2A, Himawari, and I'll talk about those for a bit. If I can get to the next. There. So where can you find all this imagery online? So I'm hoping you're mostly familiar with the various bands, or you know where to find that information. There are quick guides out there if you follow the links. They're in English, Spanish, or French. So you can find them all in different languages if you're not a native English speaker. So most of you are fluent in band talk. So Himawari data are from JMA, which is the Japan Meteorological Agency, from the MSC, the Meteorological Satellite Center. So there are lots of different areas that you can look at. I'm just looking at band 13 on the slide here, which for a HI is 10.4 micrometers compared to 10.3 for ABI. There are different areas you can look at that are scattered through the Pacific region or the Himawari footprint. Himawari is at 140.2 east. So, you know, a hemispheric view centered on that longitude. So you can look at them from Japan, and there are also a bunch of US sources as well. So NOAA has an agreement, and we have Himawari data as a result. There is a US National Weather Service forecast office on Guam that relies on Himawari data because it's too far west to have any benefit from goes west. the forecast offices in Pongo Pongo and in Honolulu also can use Himawari data, although they're more on the, Honolulu especially is more on the limb of the Himawari data, and they are primarily using Goes West data. FY4A is China's satellite. It's actually an experimental satellite, so it was launched several years ago. They're testing out a whole bunch of capabilities. And FY4B, which will become operational, was launched earlier this month. So FY4B will have information that you can look at. But for now, you can look at both FY2G or FY4A. So FY2G is kind of an older satellite, but it does give imagery over that part of the globe. And you can see some links here where you can look at it. So the at SSEC, which is where I work, Space Science and Engineering Center, there is a data browser, and the link on top here shows where you can find that, or you can go to this link from CMA, the China Meteorological Administration. So there's the JMA, the CMA, and the KMA. And I believe, yes. So JMA is an agency, CMA is an administration. And I'll let you ponder what KMA is before I reveal it on the next slide. But that's always confused me, and it's difficult when I'm writing a blog post, for example, and I want to say thank you to the Japan Meteorological Agency, or thank you to the China Meteorological Administration, just to remember what that A means. But that's my problem. You can find more information from CMA about FY, especially FY4B, which is coming soon to a web browser near you, probably hosted in China. So there's a series of interesting training that the Bureau of Meteorology VLab puts out. And the link there is to an MP4 of a gentleman from CMA who's giving information about FY4A. That was earlier. That was, I think, about a week and a half ago. So KMA is the Korean Meteorological Administration, and it has the AMI. So the ABI, the AMI, and the AHI are all close cousins. AHI and AMI have the 0.51. ABI and AMI have the 1.38, and AHI and ABI have the 2.24. So, you know, they're almost the same, except there are three channels that are swapped out. So the US decided that the green band was not needed. Japan decided that the cirrus band was not needed, and Korea decided that the cloud phase band at 2.24 was not needed. So it's very, keeping that straight is a challenge when you start looking at satellite data, but now I know. So you can find imagery from KMA at the two links. And I like KMA's pages because they also show the products. And there's archived imagery as well. So they have a very complete collection of imagery. Whoops. Okay. I thought I had, oh, it's listed there right on the page. So you can see the different bands and some products that are available from KMA. A lot of these are just RGBs. But I think if you go to that product link, you can see things like cloud top phase, derived cloud top phase, or cloud top temperature, cloud top pressure, aerosol optical depth. So any kind of product that you can think of almost that's been derived from satellite imagery is available at that link. Meteosat is the satellite over Europe, 11 channels. Some of that imagery you can view freely, some of you can't, because because of Meteosat policy, but you can see the footprint there. It's kind of centered over Africa. So you see a lot of Europe kind of on the limb and a lot of Africa. So you can see this at the CIRA Slider, all the bands and some RGBs. You can see all the 11 bands at the browser at SACC. View has basic imagery. So there are places you can look at here as well. Meteosat-IODC is over the Indian Ocean. I have a picture, no. So this is data coverage over the Indian Ocean using Meteosat 8. Again, this is available on the CIRA Slider and also on, so a more complete subset of data is on the CIRA Slider, and you can get the 4 bands from the satellite, from the data browser here at SACC. BWS-G1 is an old satellite that's been repurposed. So this is actually owned by the US Department of Defense. So it's the Electro-Optical Infrared Weather System Geostationary. That's what that stands for. And it sits over the Indian Ocean. So the Department of Defense has repurposed this so that they have ownership of the imagery, or they're not reliant on others for this important imagery over the Indian Ocean. So GOES 13 is pretty old, so I have to think that when GOES 13 can no longer function, they might take GOES 14, where it's sitting in storage right now, a perfectly good instrument that was never really used a lot, and that'll be moved over too. But that's just my opinion. I don't really know anything for sure. But the only place I know of to find that data is through the data browser here at SACC with a link there, and it shows all 5 GOES channels. And you have to remind yourself, what were those channels again before GOES-R went up? And they're listed there. 6.5 for the water vapor, 10.7 for the infrared, and the 0.64 and the 3.9. Now there's so many places you can look at GOES 16 and 17. I sent around a list. The challenge of this is if you want something old, that's a little bit harder. So for the CIRA Slider has been mentioned. That data goes back about 9 days. I'll show you this. There's a CSPP Geosphere that goes back about 2 weeks. RealEarth has GOES 16 and 17 data that goes back about a week. But like I say, there are very few sites with level 2 products. So if you want something from farther back than this, you have to go get the data and recreate the imagery. So that can be kind of a challenge. And there are lots of sites with RGB products. Many, many, many different sites. So again, RealEarth has global composites. So you can find where things are stitched together. So you don't have to rely simply on the imagery over like the GOES 16 domain. Maybe you're looking at something over in the Eastern Atlantic and you'd like to see things from a little bit farther east. So it has a function where it can stitch together GOES 16 and Meteosat 11 to give you a more complete picture. So, are there any Sli.do questions to answer? Let me look. No, nobody's asking questions. So feel free to ask questions. I mean, I'll even say you can ask them anonymously. So let's see. I've been talking for an hour. We have another 35 minutes. So let's take a 5-minute break. Get up and stretch your legs or do whatever, a comfort break as I like to call it. And I will start again in 5 minutes. And I'll just say, June, if you want to pause the recording.
So Scott, I don't know if you'll have the time or inclination, but it might, our students might be interested in seeing a couple of your blogs and how you kind of pull it together to help forecasters use some of these capabilities.
I will see if I can get to that.
Scott, we've also had some new questions come in, so you may want to take a look at those at the beginning.
Oh yeah, look at that. I guess I should look up what GEMS means.
GEMS is the Korean geostationary satellite, and I don't believe the data are publicly available yet. They're still being quality controlled and checked because GEMS just launched last year. It's a new satellite.
Okay.
But I don't remember what it stands for either. Geostationary something. Ah, Sarah knows. Sarah knows all the acronyms.
Alrighty, well, I'll answer.
It helps that you work when you work at Ball.
So how does that differ from the AEMI?
It's more atmospheric composition focused.
So does it have more channels then?
I would have to look that up, Scott. I don't remember off the top of my head. I'm sorry.
I'm looking at it online. I just don't quite see. So is it?
Are you familiar with Tempo, with the Tempo plans instrument?
No, and I see that's a question also.
Okay, yeah, it's the Korean version of Tempo, essentially. And Sentinel-4, the ESA Sentinel-4 satellite is going to be the same sort of instrument, but over Europe. That's launching in the next couple of years as well.
Well, they're polar orbiters, so.
No, they're geostationary.
Oh,
They're geostationary,
okay,
Scott.
okay.
Yeah.
Okay, so Tempo is very short wavelength. Ultraviolet, okay.
Specifically for air quality applications.
Yeah, air quality and atmospheric composition.
Yeah, composition.
Okay.
And
Well,
I believe that GEMS has a few more channels than Tempo. But yeah, other than that, they're sister instruments.
Yeah. Well, I see that it's noon, well, 18Z, and I said we'd start again now, so I guess I should start again. And there are questions. Thank you for the questions. You've stumped me, but not everybody. Are KMA GEMS data publicly available? So GEMS data, I have been informed, I did not know this, is more of, it's a satellite that has spectral bands in the visible and in the ultraviolet. So it's being used for, especially for air quality. It's similar to TEMPO, which will be launched by the US, and Sentinel-4, which will be launched by ESA, which is the European Space Agency or administration. I don't think GEMS data are publicly available because it's still in checkout phase. So when a satellite is launched, it goes into checkout phase so they make sure everything's calibrated correctly. So again, satellites like TEMPO, the question is, do you know how future geostationary satellites like TEMPO or others, by others I assume you mean and Sentinel-4, fit in and add to what we have from GOES? So they are looking at different parts of the electromagnetic spectrum. So they're different in that way. And TEMPO and Sentinel-4 and GEMS are all mostly designed, as I understand it, to help with air quality. So they are, because they're looking at shorter wavelengths, they're going to be more, those shorter wavelengths, in the shorter part of the visible into the ultraviolet are going to be more sensitive to scattering, for example. So there'll be better detectability of aerosols, I almost called them aerosol particles, I guess that's redundant, that are in the atmosphere. Do you know of a good resource, for example, a link that clearly explains how the green band 16 or 17 is created? What do you mean by clearly? There are papers out there that describe this. I can find those and send them out to you after the class. Sometimes papers aren't very clear, so I can explain in figures, but I don't have the figures. But if you look at the blue, green, and red bands on AHI, you will notice that they are very highly correlated. So you can use information from the blue and the green to approximate what you can use the information from the blue and the red to approximate what the green would have shown, especially if you include information from the Veggie channel. So that's basically how it's done. Or you can create lookup tables. The CIRA Slider has GeoColor on it, and the GeoColor product is used by taking the relationship on AHI between the blue, green, and red bands, and taking the blue and red information from GOES 16 and 17 and saying, okay, I have the relationship from AHI, I'll apply it to ABI. Given this blue and green bands, blue and red bands, I can back out a green band information. So that's my quick explanation. But like I said, I will look around to see if I can find a clear explanation of that. Looking at fire meteorology and fuel dryness levels, have you ever come across any satellite data that is able to measure moisture levels in the fuels? I think that's what SMAP was supposed to, so NASA launched the SMAP instrument, and it was designed for that kind of thing. It was a microwave instrument, but I don't believe that microwave instrument is still operational. And I don't know what kind of follow-on has occurred. If you go to the JSTAR mapper, you will see approximations of soil dryness that are derived from, I believe, from microwave data. But I don't know if there's a satellite specifically designed for that now that SMAP is not fully operational. Okay. So I feel like I've been stumped some, but you didn't stump the entire panel. So I'm going to say it's a win for the panel. I want to talk about what do you do if you, like, say you're working for someone, they say, I want to see what the split window difference looked like over Mexico back on some random date in 2018. It's going to be too far past for you to be able to find that imagery online, unless someone for some strange reason created the imagery, put it out there, and Google finds it. That it's more likely you're going to have to go get the raw data and create it. And how can you do that? So I just want to talk in the last bit about that. So here's NOAA class. I hope you're familiar with it. It's a repository of just about everything. Every satellite product out there somehow finds its way into class. So first of all, you have to log in. So there's a register widget here. So if you haven't registered, you do need to register. And the reason for that is because you're ordering data from a large cluster of data. And when it's done, they have to email and tell you where to get it. So that's step one. There is a drop-down menu here. It's kind of hard to see, but you click on it and you see the down arrow there. And once you click on it, you see all sorts of products that are available. I think I made for Amy's class, which is coming up in July, I made a quick tutorial on VIIRS data, but we're going to be looking at GOES-R data. Look at all of these. We're going to choose this partially restricted level 1B and level 2+ data products. There's also GLM data there as well, but we're looking at ABI data, so that's what you would choose. And then you can choose radiances, which is what we'll be looking at a little bit later, or you can get level 2 cloud and moisture data, or you can get products. And then the number of products is pretty impressive. So you'll notice there's there's a window here. You can scroll up and down and click on the product you want. And I just did that a couple times and retrieved all the different products that are available in class from GOES 16 and GOES 17. And I'm going to say this is for GOES 16 and GOES 17. I am not familiar with how you can get archived Himawari data or archived KMA data. I know I am blessed to work at a place that has a huge data archive. So I know we have Himawari archives here. So I can get old Himawari data. I don't know how easy it is to get if you don't have a way to get data from SSEC. And KMA has a lot of data online, but I think those are all images. So to get the raw data from there is also something I don't know, and I haven't even tried to get the stuff from China. That would probably raise some flags in the university. So you choose start and end dates, you choose GOES 16 or GOES 17, you choose, different channels, you choose full disk, CONUS, or mesos, and then you click on that, then you go to the shopping cart, you make sure you have the data you want, you click it, and then anywhere from 2 minutes to 2.5 days later, well, I guess I never had to wait 2.5 days, 2 minutes to say maybe 3 hours later, you'll get an email that looks kind of like this. It says, oh, we have your data. Here's the FTP site. Go and get it. So this is an example of VIIRS data from VIIRS data, but it would be the same thing for GOES. But once you have the data, how do you display it? So you have these netcdf files, but it's not, you can use something like NCView or Panoply to look at the netcdf files, but there are other ways you can do that as well. So I'll just show you a couple. GeoDegrid, this is a Linux only package. This is based on SatPy, and you can download it. It's freely available, and you get this fairly large gzip tarball, and then you expand that, put in a unique directory, and then you can create imagery. And I'm going to demonstrate this. So it works with AHI data, AMI data, and AHI. There should be an ABI in there as well. So here are just some of the commands you can use. You can create maps onto which you want to project the data. So you might not want to look at it in a satellite projection. You might want to put it on a lat-long grid. So here there are these different shell scripts that allow you to do that. That's what the top one is. There's a grid helper to create a map called, in this case, map name, centered at 52 north, 99 west. I believe that's up over Canada. It's 500 by 500 meter resolution, and the size is 960 by 720, and you put that information into a file. So then you invoke Geo2Grid with readers and writers. That's what the -R is. So it's saying use the ABI L1B reader, which is built in. You're going to be writing a GeoTIFF file. -P is telling the product. I happen to create a Fire RGB that I wanted to use. -G is a grid name, so that's a different grid name. So I'm going to just show you how this works. So I need to share something else. Let's see. Windows. Oh, here we go. Oh, well, let's see. Okay. Let me try this again. Okay. I'm sharing this. Okay, June, I can't share my screen again. For some reason, I'm not a host anymore.
You're not? That's interesting. Let me see. I'll make you a host again then. Can you try it?
Yep, now I'm a host.
I didn't do anything for some reason. Okay, anyway.
Who knows what? Okay. So this is working, and it always surprises me because I'm sharing a tunnel. I'm tunneling into a different machine and sharing things. So thought I set something else up. Let's see. Nope. So on this machine, I have my CSPP Geo in this particular, can I make this bigger? So the first thing you do is you tell the software where does Geo2Grid sit. I just want to make sure that's, so I do this all the time. So there's my, you have to set this environmental variable. And I'm just going to go down. So I created this little script. This is how I do things when I'm using this. So I've put those 3 different scripts into this Unix bash file, or into this bash file, where it's creating a map called TD2. So as you might imagine, I was looking at tropical storm Bill yesterday and the day before. And then we have the Geo2Grid commands, and then I have I add coastlines. So I want to put on imagery. And then I have some image magic that I use to annotate the image. So the nice thing about, I'm just gonna grab this. So it's a fairly straightforward thing. It's echoing out things that it's doing. So all I'm doing now is making a geotiff that's a true color. And then if we do an LS here, you see you have this .tif file, which is a true color image from a specific day time that's centered at whatever I specified. The number of products you can make that are built into this, it's pretty impressive. So let me just go, takes me a while. So I'm gonna just do it this way. Sorry that you're watching me type, but I'm gonna try to type accurately. So there is a way to say, okay, I have this data sitting out here. What are the products that I can create? So there's this list products. So you can get all of the data. So you know all of the possible things that GeoGrid is able to compute. And the challenge with this is my little tip for using GeoGrid. You can only specify one time at a time. It's a little persnickety like that. So it's gone out there to say, okay, what kind of products can I create given the input? So it's looking at all 16 channels. And then if I scroll up on this, which I'm going to have to do on my other computer. So you can see so you can create imagery from all 16 channels. There's the air mass RGB, the ash RGB, some true color imagery, convection RGBs, day microphysics. So the list is pretty long, and you can create your own RGBs as well if you want to. So that is one way, that's one method of creating imagery using GeoGrid. And it's pretty easy. I will put a sample of the, I've lost my cursor at the moment. There we go. I will put the sample shell file out there so you can kind of build off it. I mean, it's so much easier to modify someone else's work than to create your own, isn't it? But this is kind of giving you a way to create imagery if you have these netcdf files for radiance from ABI. There's also a tool that I like called the Satellite Information Familiarization Tool. This is available in both Linux, Mac OS, and Windows. You can download it at the link, and then you download your archived data files, so that either radiance or you can also, I believe it'll also read cloud and moisture imagery files, but you can download the radiance, and you have a window that looks like this. And then I like this one. I'm going to go back and show you how this works. So this is mostly running on with Python. So I need to get data. I need to load data into this. So I'm going to go to what's the file wizard, or just Control O like anything. These are the kind of files it can read. And we are going to look at ABI level 1B, which are radiance files. And we just hit on a click. I put them in a specific place that I now have to find, which means I have to put on my glasses. Okay. It's under SIFT. So here we have all 16 channels You can see C01 in the file name for a particular time. So I'm going to choose them all, open them up, and then step through this. It tells me what I'm loading, and then I finish it up, and then it's loaded up all that data, all the different channels. So we're looking at bands. You can step through them just to see what you're looking at. Let's see, am I on the right computer? The problem with using two computers is I push down at the wrong place. So you can step through the various channels just to make sure you have the right kind of thing there, which is kind of cool. I really like this little feature here up over Minnesota in the water vapor. I don't know what's going on there. So you can really zoom in fast and play around with this. But I want to show you why I really like SIFT. SIFT is one of the easiest ways I know of to create a new RGB. So we're going to go into Layer and create a composite. Actually, first I'm going to create an algebraic. So this is an easy way to make a difference file. So we'll just call this water vapor difference, and we'll do a difference between C8 and C10. So the upper and lower water vapor channels on Ghost 16. And okay. So there we have a difference channel between the two. I'm just going to quickly change the color map. So it's something that's not quite so big. So there we have the main differences between the water vapor. And then I might want to use that to compute an RGB. So we go here, can create composite, and then down in the bottom, which you can't see on your screen, but it's on mine, there's an RGB bounds. Let me pop this out. Oops, stay out. And move it over here so you can see it. So the red band here, I want to make something, for example, that detects cirrus clouds. So I know that the water vapor difference might be used. I should have made the split window difference. That one is really good for cirrus. But we'll change this so it's minus 50 to 20. So we have high level, it looks like high level fields are showing up. If we're going to look at cirrus, we might as well use the cirrus channel. And we're going to change the bounds on this one as well. So it's say from 0 to 0.4. Make it 0.25. And you notice how things change right away as you're moving, as you're changing. I'm going to change the gamma on this. So I'm going to make the gamma smaller. Oops, not too small. So as the gamma is smaller, you're emphasizing more of the low range of this particular channel. And then 10.35, we'll just use the brightness temperature. And you can do whatever you want for that. Let's make it look like this. So we just flipped it. You can flip the max and the min. So it's just a nice way if you want to create an RGB to play around with it before you get it. So download SIFT and figure out what you want your RGBs to look like. And you're making imagery as well, and you can if you're not looking at the RGB. So let me first of all, let me get this out of the way now. So let's pop that back in. And we want to look at the layers. So let's not look at these two. We'll just look at this. So here we have the blue band, and here we have, and you can do things like probe it. So suddenly you're probing things, so you can see the reflectance values for bands 1 and 2, and actually for all the different channels throughout here. So you see the brightness temperature as well. It has that nice little band. And there are lots of other things you can do with SIFT, but I'm going to stop this, as they say, in the interest of time, and jump back to the presentation. So I just showed you how to do it. I just showed you what kind of imagery you can look at. And I showed you how you can use it to develop RGBs. And those are shown here.
So Scott, there's a couple other questions in the Sli.do if you
Okay, let
want to
me
get that.
pull them up. Thank you for telling me. Okay. Could you please summarize a list of all the websites that can quickly look at the Earth from above? Thank you. I am going to share in the folder a list of the websites that I've been going through in these talks. So I will share it, then I'll have Gary send an email to everybody participating today that says, go to the AMS community website where you downloaded the homework from, and you'll see some supplementary documents that include a lot of these different websites. And what's the other one? Let me put my glasses on. Ah, yes, that question. The question is, when you're retrieving data from class, how do you know? I should have put this in the presentation. How do you know where the mesoscale sectors were? And there is a way to do that. Let me finish this. Find that there's a website at SCCC that has all of the mesosectors from the beginning. And I agree that is a huge challenge, because there's a big thunderstorm over my hometown back in 2018. Was a meso called on that day? And it's hard to know that, but I will find that, and that I will include that link in the in that list of links I'm going to upload into the document. But if you can't wait, if you go to sims, well, let me type it in. Let me type that in as a question. Ask. I'm just typing right now. So in the questions, I just put a URL. I guess I should have put my name down. This is a compilation of different links that Tim Schmidt, who is a NOAA employee who works here at SIMS, has created. And that link to the website at SCCC that has historical mesosector locations is one of those. So there are lots of links in there. I will pull it out and include it in the list of links that I upload to the satellite community. I just want to finish quickly here. These are other accumulators or aggregators of imagery. So you'll be talking about or you'll be learning more about ERDAP in the August training on the late July training on this. So ERDAP, the Environmental Research Division's Data Access Program, that's what it used to mean, doesn't mean that anymore. But this is a way to get information. There's a search box here too, just like with RealEarth or with NASA Worldview. Start typing in what you're trying to look for. That really will help you find things. So for example, here I looked for SSTs in ERDAP, and I have all these different things that I could have looked at. Aerosol Watch is also out there. It has a lot of different products related to aerosols. So it's another aggregator of information. And for example, today I went back and looked at the very interesting chemical fire in Rockton, Illinois that happened on Monday. So just down the road from us. Unfortunately, as you can infer from this, we had northerly winds, so we were not being fumigated by this particular conflagration. It has a very long archive as well. So if you have more questions, there's my email. I'll always answer questions. You can even call me. I'll make you look up my phone number though. 608-263-4425. Thanks for your attention. Enjoy using the satellite data. And I hope you find it as really interesting and beautiful, really, as I do. I mean, I've been around for a long time, so I remember GOES 13. And I remember when we went from GOES 8 to GOES 12, and that's like, wow, this looks a lot better. But going from GOES 13 to GOES 16, oh boy, it is so beautiful. I can't get enough of it. And that's all I have right now. Bill suggested, though, that I show some of the stuff that I do. And why don't I do that? Let's see. So I need to share something else. There. Okay. So I mentioned to blog. So for example, if you go to the SIM satellite blog, there was a tropical system in the Atlantic Ocean. So I made some imagery. This is just grabbing images, beautiful sheared system on late Monday as it was just before it was named. So you see the surface circulation. This was created using, CSPP geosphere imagery. This is a display system from SIMS. And the thing I try to do when I make these blog posts is to, how are they using satellite information? In this particular example, there was an ASCAT pass with scatterometry that showed very strong winds to the south of the system. And so we have a beautiful example of a sheared system there, and then a little bit, 10 hours later, it's looking a lot less symmetric. And if I scroll down a little bit farther, oops. So here we have a VIIRS pass. So NOAA 20 overflew the system shortly after midnight. And at that particular time, so this is day-night band imagery on top of sea surface temperature estimates, and then just the 11.45 micrometer I05 band from VIIRS. And you can see in the day-night band imagery, there's a little flash of lightning. You can kind of see the cold cloud top associated with that. You can see how the storm is aligned right on the north wall of the Gulf Stream. It's a nice symmetric system at that point. So much more symmetric than it was earlier or later. So probably, is probably with its best organization at this particular time. So these pictures always tell a story. And my job as a blogger is to take the pictures, make a coherent story, and write it in not very much time because I don't have a lot of time to do it. If you aren't familiar with the SIMS satellite blog, there's a satellite liaison blog as well that shows GOES 16 imagery. The SIMS satellite blog has more, I would say it has more stories, blog posts about things happening internationally. That's not always the case, but usually. Here's the one on the chemical fire in Northern Illinois. And I had another one. I didn't write this particular one, but it shows you how nice. And how do you find near surface winds over the South Pacific? So this is looking at SAR data over the South Pacific, and it's comparing it to derived motion winds from GOES 17. So a nice way to compare data. If you have forecasting responsibility way out over the ocean, how do you know how strong the winds are out there? So I don't want to take too much. I could talk about the blog all day or satellite imagery all day. I'm just going to stop right now and say thank you. If you have any questions, you have my email. And let me look in the Q&A. Do we have anything new? No, I hope this was helpful. There is a survey that you will be getting, or you have gotten, or that you can access, or all three, that we want feedback. So we're always creating new short courses. We're always curious to know how useful this was. So there are maybe 5 or 6 questions. It'd be great if you could answer them. I'd appreciate it. The committee would appreciate it. And also consider, if you're an AMS student member, you can become a student member of any committee. So the Satellite Meteorology and Oceanographic Committee could use student members. I'm also on the EIPT committee. They're always looking for student members. That's Environmental Information Processing Technology Committee. There are Python, I mean, there are, you know, hundreds of committees. So volunteer as a student and that's a great way to meet people. Let's put it that way. Anyway, that's all.
So Scott, I wanted to slide in a little bit and remind people that the AMS in January is going to be in Houston. There will be a student course there. And then there will also be a satellite, day-long satellite workshop as well. So folks here, we got your email, so we'll probably feel free to send you some information on that. We look forward to you joining us in Houston in January.
Okay, this probably ends the session. Let's give a round of applause for Scott, interim doctor. Thank you, thanks a lot. You can do the reactions in the lower right corner by your shaking the hands. I like I've said a few words is that the summer is a good time that that you may have ample of time to maybe take some exercises that we assigned for, and yeah, let's carry some time here. The purpose is to try to let you learn a little bit of what you cannot learn from textbook. So with that, we will end the session, and the videos will be posted. We will follow up with you. And the next session, next training will be in July 7th. Yeah, thank you.
I always like to see who's walked away from their computer at the wrong time. That's what I assume. I'm kidding about that. See ya.